Okay, now today we'll be talking about ionic bonding for chemistry. And what are some of the things that you need to know is mainly how to actually draw ionic bonding or to define what's ionic bonding. There are also some dot and cross diagrams that you will need to know how to draw. Naming the chemical, the ionic bonding compound as well as the chemical formulae. And finally, a very commonly test item is to describe the structure and physical properties of ionic compounds. When we look at physical properties of ionic compounds, we are looking at three main things. We are looking at the um, the high melting and boiling point. Second one, we'll be looking at electrical conductivity, and finally the solubility of ionic compounds in either water versus um, in organic substances. Okay, now let's take a look at the first part where at this section, right, you are required to be able to describe the stable electronic configuration of a noble gas. So in our previous chapter, we talk about in atomic structure, we we discussed that there are actually ways to actually represent electronic configurations of a neutral atom from the periodic table, where the first electron shell will be able to take out a maximum of 2 electrons. The second electron shell will be able to take out 8 electrons. Then subsequently it's also 8 electrons. Okay, but in your syllabus, you will only be required to only understand the first 20 electronic configuration. Um, Having said that, in the later few chapters, you will also understand that the identification of the valence number of electrons goes according to the group number, whereas the number of the period will indicate the number of electron shells that is involved in an atom. Okay, so first to start off with, we look at a full complete electronic configuration or elements that has these properties, right? They are generally known as noble gases, and these elements they tend to belong to the group 0 of the periodic table. The group 0 is found on the right hand side of the periodic table, and they are namely helium. He is the chemical formula for helium. Then Ne is neon, then argon, and so on and so forth. Uh, Atoms of the noble gas, they tend to be stable and unreactive. In other words, in exam or in books, you'll see the word inert. Inert has the same meaning as stable and unreactive. And because they are stable and unreactive, they tend to also exist as single atoms as they do not require any additional electrons, neither do they need to donate any electrons to fulfill the stable state configuration. So noble gases, they tend to have full or complete outer shell. Now, outer shell doesn't mean that the inside of it. Insides are already full because in order to move to the next shell, you have to have the complete shell for to have the complete inner shell. So when we talk about complete outer shell, we are talking about the valence electron shell. Okay, the one right at the outside. Right? And one common statement that they always ask is for neutral atoms, right? Is it true that all elements, okay, or all group 0 elements contain 8 valence electron? The answer is wrong. Instead, for helium is the only exception where it actually have a duplex configuration, meaning you see this is 8, 8, 8, 8, 8 valence electron shells, 8 8 valence electrons in the electron shell. However, for helium, it tends to only have 2. Why? Because the first subshell, the first electron shell, maximum can only take 2 electrons. So this is the only exception to the rule for um, group 0 elements. So why do atoms react? Most of the atoms, right, from the other elements, they tend to be reactive because they do not have a completely filled electron shell. In other words, their noble gas structure is incomplete. How we can see this is later in the previous chapter, we saw that for group 1 to 7, their outermost shell, they are not at the 8, or even for hydrogen, it's not at 2. It's at, there's some form of missing electrons. So what we saw is that for group 1, group 2, group 3, you tend to be easier to lose the electrons Group 1 will require to lose 1 electron. Group 2 elements will be 2 electrons, and group 3 neutral atoms will be 3 electrons. Whereas when we look at 5, 6, 7, 5 gain 3, 6, group 6 gains 2, and group 7 gains 1 electron to fulfill that noble gas structure. The reason why they use the word noble gas structure, right, it's because noble gas structure has the same meaning as completely filled valence electron configuration. Okay, and atoms of these elements, they tend not to lose atoms of these elements tend to either lose, gain, or share outer electrons to attain the noble gas configuration. So in the scenario of losing and gaining the electron, we are tentatively looking at ionic bonding. Whereas scenarios that allows you to share the electrons, right, we are looking more of covalent bonding. Now, for the stable electronic configuration of a noble gas, we are looking at two. Like what was being discussed, atoms can either gain or lose electrons to attain the noble gas configuration, while chemical bonding, the atoms will tend to share the electrons to attain the noble gas configuration. And this is covalent bonding. So what is then the difference? Gaining or losing means I give you. From one person, I give to another person, or I receive from another person to myself. I do not have to return in some ways. On the other hand, sharing means both of us share the same thing together. It's like, let's say, I give an example of a human, two different humans are for both. The red color will represent the item that we either transfer over. So in this case, when we talk about ionic bonding, it means that this red stick we actually pass on to the other, and such that the other person is not actually like in a way receiving this stick again. However, when we talk about sharing, right, at all times, right, there will be some form of touching or some form of sharing of the item, the red stick together from two different person. So that is generally how it's being differentiated, where the red stick represents the electron, and the person represents the atom. Now, when will then be the ionic bonding, and when will it be covalent bonding? It depends on the groups of the element. So if we are talking about ionic bonding, it's between metals, elements from metals plus elements from non-metal. Okay, elements of metals are generally from your group 1, 2, and 3. Non-metals will be your 4, 5, 6, and 7. On the other hand, for covalent bonding, we are talking about non-metals with non-metals pairing. And in this case, when we talk about these, it's your group 4, 5, 6, 7 matching with another group 4, group 5, group 6, group 7 element. Your group 0, they tend to be noble gases, and they tend to be occurring in single atoms. So they don't really need to share, gain, or even lose any electron. So what happens when you either lose or gain the electron? So what happens is you always start off as a neutral atom. A neutral atom is basically what you see from the periodic table. The number of electrons, the number of protons, all this and that. From a neutral atom, because it's not very stable, due to it having an incomplete electron shell, you tend to either gain electrons or you tend to lose electrons. And by gaining electrons, right, you are gaining more negative charge. Why? Because in the previous chapter, we learned that electrons are more negative. This will give rise to a situation where the atom, right, will have more electrons than protons. Because if you remember in a neutral atom, right, number of protons is the same as the number of electrons. But for a neutral atom, once it gains electron, after gaining more electron, you tend to be more negatively charged. And in this case, when you actually become more negatively charged, you form the ion that what you call as anion. Anion are generally the symbol and they have a negative charge on it. The number later the square bracket will represent the number of electrons that has been gained. On the other hand, if the neutral atom lost electron, in this case, you will have lesser electrons than protons. And because protons are positive charge, electrons are negative charge, overall, you will have more positive, overall positive charge as you have more protons as compared to electron. This will give rise to the whole atom, the whole ion, right, to be more positive. And hence, you form something called the cation, where if you represent the symbol, it is something plus. Okay. Now, the way of writing these is not so much of writing the symbol first, the minus, then the square bracket. Rather, in conventional term, what we will tend to write is the number of electrons that has been gained or lost, and we will write the charge. In this case, for the top one, because you gain electron, there is more negativity than positive charge, therefore you put a minus. On the other hand, you put a plus because there is more protons, which is more positive charge. Okay, this is the more layman term of explaining. As you go further, you'll realize there are other considerations like shielding effect and nuclear charge in your exams. But that's not the scope for O-level chemistry. So generally, what is an ion? This is like a recap, is that atoms, they have neutral atoms to be more specific. They tend to have an equal number of protons and electrons, and if they either gain or lose electron, it will result in a charged particle known as an ion. This is where the number of electrons is no longer the same as the number of protons. And being positively charged, like what I said, I shared the explanation, they are known as cations. This would mean they have more protons than electrons. The other one is you would have lesser proton than electron. That means you have more electrons. Now, one thing to note is which is the scenario, which group, right, will actually be more prone to gain electron and which will most probably be there to lose the electron. So for cations, we tend to lose electron. Anions, we tend to gain electron. So in order to lose the electron, right, it must be very easy to lose the electron. So what we can see is your group 1, 2, and 3, they tend to lose electron more favorably as compared to your non-metals. These are your metals. They are non-metals, which tends to accept it easily, which are your group 4, 5, 6, and 7. Now, why is this so? It goes back to how we look at the whole structure of the valence electron. Okay, so in order, like what was being shared, atoms of metals that lose electrons to form positive ions, we are called the cation. And one way to remember is cat is with a positive symbol, whereas anion, it has an M in it, so it's negative. So when we look at a neutral atom like this, and this clearly because you have only one valence electron in the outermost shell, it is easier to lose the number of electrons as compared to the noble gas, to achieve the noble gas configuration, as compared to gaining 7. So you have two scenarios, either you gain 7 or lose 1 electron, which will require lesser energy. It will be the one to lose the electron to reach the eventual outgo of a stable octet configuration. Octet because it's 8 here. Now, where is then the marking will be at 4. At 4, should it gain or lose? This one is subjective, but at the same time, in O-level, they try not to use a group 4 element as an example to explain the electronic configuration. So in order to form the sodium ion, we would see that you will be required to know how to draw something like this. Why? Because eventually when you are required to draw the ionic compound in totality, you will need to draw two or more of the ion within the same diagram. So what we can see for here is that the middle ground, we always tend to write the symbol of the atom that we are talking about. And by losing one outermost electron, this is the neutral one, we realize that you will be able to form an ion. And to represent an ion, we tend to have squarely brackets to cover it, as well as the symbol. This symbol represents whether the overall charge is it positive or negative, or in other words, whether it has lost the electron. Okay. The interesting thing is we don't actually write the number for 1 to simplify the process, but anything more than 1, like 2, 3, 4, we tend to actually write it in. Okay, for calcium, it is in a way this way, whereby you lose 2 electrons to form a cation of Ca2+. This symbol must always be drawn outside the square brackets and not inside. It has to be a superscript so that it can be represented rather than a big 2. So these are some of the common cations and their charges, which you can see from the top. There are some special ones that you have to remember, but more or less in exam, they tend to ask you to draw with respect to the group 1, group 2, group 3, 4, 5, 6, 7, not so much on 4, and maybe group 8. Transition elements not really tested. That's why it's only the first 20. Formation of anions is the other way, whereby the atoms of nonmetals tend to gain electrons to form negative charged ions called anions, and in this way they achieve the noble gas configuration. So likewise, everything is the same, neutral ion, neutral atom. Where it starts to actually gain the electron, it will actually form the square bracket, but you change the charge over here. In exam, rarely will you be required to actually draw the calculations, but you will need to be able to come up with at least this whole structure over here. Do you have to write the 288 on top of the thing? Not necessary. Okay, this is not required, but you are required to indicate the symbol as well as the electron. Now, how do we represent the gain electron, right? Reason being is we don't, because in exam we can't use another ink color. So rather than using red color, we tend to just put a cross to represent the extra electron that is being gained. Now, what we can see also, right, is that where these electrons suddenly appear, where they appeared from. This electron appeared from the other atom or the other ion that has the other atom that has actually lost the electron. So when one atom lost the electron, it will be gained by another atom to form the ion. So this is one way whereby it forms an ionic compound, because we can see that for group 1, group 2, group 3, they are easier to actually lose the electron, and group 4, 5, 6, 7, they are easier to gain. That's why for ionic compounds, it's usually formed between a metal and a non-metal due to this relationship. Okay, oxide, you will look at 2, so you can just draw an O, one oxygen, and then you can mark an X to represent the electron. And not to forget, over here we always write the symbol first. We'll write the number first, then the symbol. Okay, if you were to write -2, you'll be marked wrong in exams. Okay, and what happens is from the ions with the charge, we are actually able to identify what are the groups of the neutral atoms are from. So if let's say you are minus, right, it means that you have gained 1 electron. Okay, minus, gain 1. This one is you gain 2, gain 2. So how will we work it out that the group number, it depends on 8 minus 1. So if you have 8 minus 1, you have group 7. Group 7. 8 minus 2 electrons, group 6. Group 6. Now, definitely we cannot use this rule all the time. Like for example, helium He, or hydrogen H plus. We can't take an 8 to minus. So we only have to remember consciously that the first few elements, the first two elements actually we go by 2, because that's the maximum valence electron that the outermost shell can take in the first subshell. Okay. I will pause here. If you have any questions, do recap the thing, and then we will revisit the other part again. Thank you.